Okay, we are going to attempt to solve a system of equations by substitution. I need two equations. Both equations have two variables. In this case, they both have an x and a y. And in order to solve a system of equations by substitution, I need one of the variables to be by itself. See how this y is by itself? So in the first equation up here, the 2x minus 1 is equal to y. I don't know what y is, but I do know that it's equal to 2x minus 1. So now in the other equation, I'm going to substitute the y. So see this y here? I'm going to take this y out because I know that it's equal to 2x minus 1, because that's what the first equation says. Now, it used to be 6 times y. So now instead of 6 times y, it's 6 times 2x minus 1. And now I've got one equation that only has x's in it, so we can solve it. It would be the same thing that you had to do in Chapter 2. So I'm going to use the distributive property for this one. And 6 times 2x is 12x. 6 times 1 is 6. I'm just going to finish my equation now. Okay, I'm going to drop my line. Now on the left side of my equation, I have 12x's plus I have 4x's. So altogether, I have 16x's. I still have this minus 6, and that is equal to 10. So I'm just solving my equation now, adding 6 to both sides. And I get 16x equals 16, divide by 16, and I get that x equals 1. Now in the beginning I had two equations with two different variables, so when I'm done I need to have two different answers. So far I have one. I know that x is equal to 1. So what I'm going to do is take this 1 and I'm going to put it in place of x, because now I know what x is. So if x is 1, well then y is equal to 2 times 1 minus 1. So y must equal to 1. So I happen to have two answers now, and the way that I'm going to write my answer is a point. Because in solving a system of equations by graphing, if we had graphed these two equations, they would have intersected at the point 1, 1, so that is the solution. Okay? If I wanted to check my answer, I could go back to the original equation. My other equation was 6y plus 4x equals 10. So if I put a 1 in here for y and a 1 in here for x, I should get 10. 6 times 1 is 6, 4 times 1 is 4, and when I add them, I get 10, so I know that it works. All right, let me go through another example for you. I'm just going to go through a bunch of different examples. This time, I've got x by itself. I still have two equations. Each equation has two different variables. But in this one, the first equation has x by itself. And so since x is equal to 5y plus 3, what I'm going to do down here is I'm going to take this x out, and I'm going to substitute a 5y plus 3. Now notice it wasn't anything times x, so I'm not using the distributive property here. I'm simply going to take 5y plus 5y, which is now 10y, plus 3 equals 8, and I'm going to solve that equation. So I'm going to subtract 3, and I get 10y equals 5. I'm going to divide by 10. Be careful, I'm dividing by 10, not the other way around. So my answer is that y is 1/2. Again, I had two equations, two variables, so I need two answers. So if y is equal to 1/2, I'm going to go back up here and put 1/2 where the y is. So if y is 1/2, then x must equal 5 times 1/2 plus 3. 5 times 1/2 is 2.5, and 2.5 plus 3 gives me 5 1/2. So there's my x value, and I'm going to write my answer as a point. The x goes first, just like we graph a line. So my answer is 5.5, 2.5. If I had graphed those two equations, that is the point where they would intersect. Okay? Go back to my original equation. If I had done 5 times 1/2 plus 1/2, no, sorry. if I had done 5 times a half plus 5 and a half, I would get 8 as an answer, and my answer would be right. Okay, let's move on to another example. Okay, so now this one I have 2 equations, and I have 2 different variables. Neither of them, though, is y by itself. So that's okay, though, because I can do something about that. In the first equation, if you notice that this y doesn't have a coefficient with it, so it might be kind of easy. If I just subtract 3 x's from both sides, I end up, maybe. If I subtract 3x from both sides, what I end up with is y equals negative 3x plus 5. I can't add the 3x and the 5 together because they're not like terms. So basically this 3x gets moved to the other side and it becomes a negative 3x. Now y is by itself. I'm just going to rewrite everything here. So I'm going to have 4x plus 5 times all that stuff. And that's supposed to equal 3. So remember, this used to be a y, and since y was equal to negative 3x plus 5, I substituted that. I do need to use the distributive property in this one. So I get 4x plus negative 15x plus 25 equals 3. Combining like terms on the left, I end up with negative 11x plus 25 equals 3. Subtract 25 from both sides, and I get negative 11x equals negative 22. And when I divide both sides by 11, I get x equals positive 2. So I have my x value is 2. I still need to get the y value. This time I'm going to plug 2 in here because I know that x is 2. So now y is negative 3 times 2 plus 5. So negative 6 plus 5, y equals negative 1. And my final answer, I'm going to write on the left over here, my x value is 2, my y value is negative 1. Okay? Last, I think that's the one that I just did for you. All right. Okay, now we're going to solve a system of equations using the addition method. Some people are used to calling it the elimination method. Some people call it the addition method. It's the same exact thing. The idea is I still have 2 equations. I still have 2 variables. Instead of solving by substitution, I'm going to add the equations together. And I am hoping when I add them that one of my variables cancel out. And it does here. If you notice, I have a negative 2y and a positive 2y. So if I add these 2 equations together the way they are, 3x plus 5x is 8x. Negative 2x plus 2, or sorry, negative 2y plus 2y is nothing. And that equals 5 plus 3 is 8. And now I can just divide by 8, and I get x equals 1. So if x equals 1, I still have to go back into one of the original equations to find y. It doesn't matter which one. In this case, it looks like they're both about the same as far as how easy it is. So I'm going to do the second equation. So I'm going to go up here and do 5 times 1 plus 2y equals 3. So I get 5 plus 2y equals 3. Subtract 5. 2y equals negative 2. Divide by 2. So y equals negative 1. Again, my final answer, x value is 1, y value is negative 1. I'm going to check this one just to see if it works by plugging 1 in for x in the top equation and negative 1 in for y. 3 times 1 is 3 minus 2 times negative 1 is negative 2. It's supposed to equal 5, and it does, because when you add a negative, you end up with, when you subtract a negative, you end up adding a positive. So that does work. So that would be the addition method since I added the equations together. All right, another example of the addition method here. Now this one, if I went to add those 2 equations together, neither of the variables would cancel out. So I have to just do kind of like some math magic to it. I'm going to have to just kind of change that first equation. And I can do anything to an equation that I want as long as I do the same thing to both sides. So if I look at that first equation, if that y was a negative 5y, then they would cancel out when I add them. So you kind of have to look ahead a little bit at what you want the variables to be to work for you, and then we're going to manipulate it. So as long as I multiply both sides of that first equation, everything, by negative 5, I'm going to end up with a negative 5y. So I'm going to rewrite that down here though. So negative 5 times 3y is negative, 3x is negative 15x. Negative 5 times y would be a minus 5y. And then negative 5 times 5 is a negative 25. Now I'm going to add those two equations. 4x and negative 15x is negative 11x. Those cancel each other out. 3 plus negative 25 is negative 22. And now I'm just going to divide by negative 11. And I get x equals negative 2. Again, I'm not done yet because I have two equations, two variables. I need two different answers. So I have the x value. I'm going to go back up. It doesn't matter which equation. I'm going to do the first one. And so I'm going to have 3 times negative 2, because that's what I got for x, plus y equals 5. Negative 6 plus y equals 5. Oops, I can tell I messed up right away. So if you notice where I messed up here, I'm going to have to add 6 to both sides, and I would get 11. That's not going to work out for me. So look right here. I divided by a negative 11, which is right, but on the other side I did not. I should have divided by a negative 11. A negative divided by a negative would be positive 2. So this is going to have to be a positive 2, which is going to give me a positive 6. Now I'm going to subtract 6 from both sides, and I get y equals negative 1. So there is my two answers. And to double check that I'm right, I'm going to use that second equation and check it out here. So 4 times 2 plus 5 times negative 1 should be 3. So 8 plus negative 5 does equal 3, and I know that I'm right. Okay, solving, here's another one. So if you notice in this one, my x's and my y's, if I added them right now, nothing would cancel out. When you add fractions together, you have to have a common denominator. And sometimes when you add two fractions, you're going to need to change both fractions so that you have a common denominator. That's going to be the case here. My top and my bottom, I'm going to need to multiply both of these equations by something. It really doesn't matter if I want to eliminate the x's or the y's. I'm going to decide to eliminate my y's, just because right now the top y is negative and the bottom's positive. So if I multiply this top equation by 3, I'm going to end up with a negative 15y. So 3 times 2x is 6x. 3 times negative 15 or negative 5y is negative 15y. And 3 times 13 is 39. In the second equation, I want to have a positive 15, so I'm going to multiply everything by 5. 5 times 5x is 25x. 5 times 3y is positive 15y. And 5 times 17, let's see, 50 plus 35, that's 85. Now I'm going to add them. 25 plus 6 is 31x. These cancel out. And on the other side, I'm going to get, let's see, 9 and 5 is 14, 124. Dividing both sides by 31, I'm going to get 4. So x is equal to 4. Plugging that back in, it does not matter which equation I plug it into. I'll just do the first one. So 2 times 4 minus 5y must equal 13. 8 minus 5y equals 13. Subtract 8. Notice I'm subtracting 8 because 8 is positive over here. And then I have a negative 5y left. Equals 5. Divide by negative 5. Y equals negative 1. Final answer should be 4, negative 1. I'm going to check that really quick since I made a mistake last time. So in my bottom equation here, I'm going to plug in a 4 for my x value and a negative 1 for my y value. That leaves me with 20 plus negative 3 equals 17, and that works, so my answer is right. Hopefully this all fits on in one video here for you. Okay, so last, I've got 2 different problems up here for you. And I just kind of did this for 2 reasons. Number one, if you look at the problem on the left, those 2 equations, the way that it's set up, how x is by itself, if I had a choice, I would solve that system by substitution. X is already by itself, so I am going to substitute this negative 2y plus 5 in place of x. So I'm going to rewrite that. 2 times negative 2y plus 5 plus 4y equals 17. I am going to have to use a distributive property, so I get negative 4y plus 10 plus 4y equals 17. Solve my equation. These are on the same side, so they actually cancel out, and I end up with 10 equals 17. Now, this is a special case. So when both variables cancel out, so I have no variables left here, and I have something that is not true. This is not true. 10 never equals 17. So if that is not true, my answer is no solution. So that happens sometimes, okay? Both of these variables ended up canceling out. I have none left. It is not true. So my final answer that I need to see you write on your paper is no solution. On the other side, now this one, I have my x's line up, my y's line up. I would choose to solve this one by the addition method, simply because no variables by itself. You could still use substitution if you want, but I would do it with the addition method. And maybe I would choose to eliminate my x's. So if I was going to eliminate my x's, I would need to multiply this top equation by 2, because then I would get a positive 6x. So when I do that, I get 6x minus 8y equals negative 2. Add my equations, my x's canceled out like I wanted, but my y's cancel out also, so I have nothing on the left, and I have nothing on the right. Now that is true. So if my variables cancel out and I'm left with something that is true, then I want you to say my answer is all reals. So in other words, really this happens to be the same exact line. If I graph them, they would be the same line on top of the other. The one on the left, if I graph them, they would be 2 parallel lines that never intersect. Okay? So here we go. So you may solve a system of equations using substitution, or you can solve a system of equations using the elimination method or the addition method. It really doesn't matter. It's a matter of preference, which one works better for you. Sometimes you get answers that is no solution or all real numbers, but most of the time your answer is going to be a point. You have a value for x and a value for y. Okay, let me know if you have any questions.